Okay, so the point of this sheet is to organize all our different formulas that we've been using in this unit. So some of them are new and some of them are old. So the first one is the area of the circle. We have been seeing that one. Area is going to be pi times the radius and then square. Circumference. Circumference is pi times diameter. Um, Technically, you could say 2 pi r, because if you take 2 and multiply it times the radius, you do get the diameter. I'm a bigger fan of pi times diameter just because it's simpler in my eyes, but hey, whichever one that works. Rectangle, we've seen that one as well. We played with that as length times width. Now, it's the next three that are starting to get into some of them we haven't seen as much. So your triangle, what we want to realize is a triangle is simply half of a rectangle. As a poor of a rectangle that is. So even though a rectangle would say length times width, we actually say base times height. But since we only want half of the rectangle, that's why we have to divide it by 2. This works even in a triangle like this, because even if we do this, all right, and then you can kind of see if we chop this up, this and this is what we wanted. You can see the two rectangles and that it's only half the amount. So again, base times height divided by 2. So really what we're after here is we're after the right angle. The right angle is where the base and the height meet at. So if we go back to this particular one, that first one we see there, your base and your height, this would be your height, all right? That would be your base. So there's your base, there's your height. They would have to give you that information because that's where the right angle would be. Not this side of the triangle because that's leaning the side. For this guy, there's your height, there's your base, so that would be your right angle that's there. And again, you can see that's what we would use to find the rectangle. But the main thing is if you can find the right angle symbol, that's your base and that's your height. Same thing with your friend, the parallelogram. The area is simply base times height. And the reason why is if you actually cut off that triangle and slip it right over there, what'll end up happening is you'll have a nice, all right, rectangle when you do that. So what you can see is back in the original measurements there, the original kind of site that we're dealing with, that the base and the height again meet at the right angle. So there's your height that we're dealing with. All right, and that's what we saw right there, which was from right there. All right, that is your height. And then your base, I'm going to use this guy up here because again, you can see where the right angle is at. So for a parallelogram, it's just your base and your height. And again, they always meet at the right angle. So typically you'll see something like this, and then you'll see a right angle symbol. So this would be your base, and then this would be your height. And again, because of that right angle symbol. The last one's the trapezoid. Now, here's the thing about it is you could break up your trapezoid into smaller shapes. Highly inefficient, and it's going to cause problems, issues, concerns, frustrations, anger even, when you're trying to solve for some of them because you won't have enough information. So what we want you to notice here is visually of what's going on. All a trapezoid is, so first of all, it's different than a lot of your other shapes here because a trapezoid only has one set of parallel sides, whereas a parallelogram has two sets, top, bottom, left, right. rectangle, top, bottom, left, right, square, top, bottom, left, right. So of your four-sided shapes, the trapezoid is kind of the different one because it only has one set of parallel lines. In this case, it's the top and the bottom. In this case, it's just the left and the right. In this case, it's just the left and right. So all these are examples of trapezoids because there's only one set of parallel sides. What we want you to notice is if you take a trapezoid and you actually cut it in half, if we take this piece, so if I cut it in half, so I've got this guy right there. If I take this guy and flip him here, he actually does this. Let me make sure I get it correct there. There we go. He actually does this, which you can see actually is a parallelogram. And that's it. So a trapezoid, when cut in half, is a parallelogram. So what we do is we call the one parallel side base 1. We call the other parallel side base 2. And then just like before, going straight up and down, where your right angle is at, that would be your height. So if we kind of look at the drawing there, that was base 2. That was base 1. All right. And then again, you have your height that we're dealing with. So the official formula here is you take the height and you multiply it by the two bases added together, because that'll give you the entire distance across the bottom times the height. But remember, the height there, it was only half the amount. So it's base 1 plus base 2. So again, add the bases together. We multiply it by the height, but remember, we cut it in half. So we didn't use the entire height. We ended up cutting in half. So there's the formula that we use. In this particular case, someone's knocked the trapezoid over. This is your base 1. There's your base 2. This right here would end up being your height. All right, again, a base 1, a base 2, and then this particular guy right here would end up being your height. Again, it's like someone knocked it over. So if you'd like to kind of redraw it out, then you can see, oh, base 1, hello, base 2, and oh, you're my height because it makes the right angle symbol right there. We didn't have to work inside the particular shape. So again, good thing to have these guys written down all in one particular condensed area. If you're printing out the paper, fine. If you're just writing them out on a separate sheet of paper, hold on to that paper. It's nice when we kind of condense things together. All right, there you go.